Good day, students. In this clip, we're going to be going over the third set of conic sections, the hyperbola. So let's write down the title of the notes. Conic sections, the hyperbola. Okay, the hyperbola. All right, so we're going to take a look at one example where we will list all the properties and graph and then fully label the resulting graph of the hyperbola that we created. So let's write down the instructions first. Example 1. Find the center, direction of central box, um, C of the foci, C of the foci, um, and the eccentricity, the eccentricity. Okay. All right, and after that, you're gonna graph and label the hyperbola completely. The hyperbola completely. Then state the meaning of your result. Okay. All right. So let's take a look. This is the example we're going to be looking at. We're going to be taking a look at x minus 2 square over 4 minus y plus 1 square over 9 equals 1. Okay. So basically, this is the standard form. Alright, standard forms are the forms we like because it's easy to find the properties without doing any processes. But if it's a general form, then we have to use completing the squares to put it in this form before we can find the properties. Okay, so let's write out properties, and let's find out what they are. Alright, so first thing we want to find is the center. So we know the procedure, right? You do the opposite of the number next to the x for the x coordinate, which is 2. Opposite of the number next to the y for the y coordinate, which is negative 1. Now we're going to do direction of central box. Direction of central box. That central box determines the orientation of the real and the imaginary axis. Okay, so we're going to go square root of 4, which is 2. We're going to go 2 units side to side from the center, and this is going to be we can call the transverse axis. It's going to be the transverse. And then square root of 9 is 3. And then that's going to go up and down. Since it's minus, this is going to be the imaginary axis. Okay? You can also call this the real. Alright, this is the real one because it's positive, and then the minus 1 is imaginary. Okay? Alright. Now we need C for the foci. For that one, you're just going to have C equals the square root of the bigger one. Well, it doesn't really matter. 4, since you have a minus, you're going to plus 9, okay? Which is root 13. Remember, you always do the opposite of what the sign is, alright? So root 13, which is approximately, if you work that out, you can work that out in your calculator. Let's see what that is. The square root of 13 root 13 is 3.6. Let's just use 3.6, okay? So it's approximately 3.6. Alright, so what direction do we go? You always go in the direction of the real or transverse axis, okay? In the case of the ellipse, you go with the bigger one, but in the case of the hyperbola, go with the positive one, because this one is imaginary. It doesn't have anything in it. So this one's going to go side to side. Okay? Alright, so we have the C for the foci. Now the opening, what is the opening of our hyperbola? Since the x direction is the real, the hyperbola opens in the direction of the real one. So this is going to be, it opens side to side. Alright, so our hyperbola is going to look something like this. Now eccentricity. For eccentricity, remember for the ellipse, eccentricity, for the ellipse, we had c over the major, right? But in this case, the major is like the real axis, so it's going to be c over the real axis, okay? So c is root 13. The real axis is 2, so it's 2 over root 13, okay? And that's approximately 1.8. Alright, so there goes the eccentricity. Now let's go ahead and generate our graph. We have 2 and negative 1 as a center, so our graph is going to be centered going to the right and then down, which is going to be in the 4th quadrant. The center is going to be in the 4th quadrant, okay? So let's go ahead and sketch that to our coordinate system, like that. Alright, let's move my x-axis up a little bit. Alright, so the center is negative 2, 1, so we're going to go right 2 units, and then down 1, and that goes my center. Alright, so I'm going to create the central box next. So for the central box, I'm going to go 2 units to the side, so 1, 2 to the right, and then 1, 2 to the left, and then up and down 3, 1, 2, 3, and then down 3, 1, 2, 3. Okay? Alright, now let's create the central box. Now everything I'm creating right now should be done in broken lines, okay? Because we haven't drawn the graph yet. So use a broken line to create the central box. Like that. Like that. Like that. You don't need to use arrows, just use a broken line, okay? So use broken lines to create the central box. So there goes your central box. Okay? Now the next thing we're going to connect is we're going to connect the diagonals to create our asymptotes. Alright? We're going to connect the diagonals. So from this to this, through there, that's one asymptote to help us construct our graph. First asymptote, too long, a bit shorter. So all we're just doing is connecting diagonals, alright? So there goes your first asymptote, and then your second asymptote goes through there. Like that. Okay. And then put arrows because they're lines. We're going to be stating their equations very soon. Now to draw the actual parabola, remember the opening is side to side, so we're going to draw a parabola here and a hyperbola here, okay? So draw it as best as you can. You go close to the asymptote and then you curve out like that. And then this one goes down close to the asymptote and then you curve out like that, okay? Put the arrows there. And then this one goes close to the asymptote and then it curves out like that. And then the other one goes close to the asymptote and then basically curves out like that. Okay? Alright, now we're gonna draw the axis. This axis that goes right through the center has a special name, and then this other one too has the special name. So let's draw those. Shift this one to the right a little bit. Okay? All those axes should have arrows pointing and out. Alright, now let's go ahead and start labeling our creation, our hyperbola, and all the components. I'm going to start by labeling the center. Alright, so right here is the center. What are the coordinates of the center? It's negative 2, 1. And then we have the foci. The foci is 3.6 units side to side. So I'm going to go 1, 2, 3.6 is that our center. So that's F1. F1 is basically 5.6 comma negative 1 because I started from the center and then I started from this. Oh well, I messed up my center. My center is 2, negative 1. Center is 2, negative 1. Sorry about that. So I started from the center and then I went 3.6 units. So if I add 3.6 units to this, I'll end up with 5.6. Okay, starting from 2. And then I added 3.6 and I ended up at 5.6. Alright, so that's my F1. My F2 is going to be going the other direction. 1, 2, 3.6. Right there. So this one is F2. F2 is going to have the coordinates negative, is going to be negative 1.6 comma negative 1. Okay, because we're starting from 2, and then we're going 1 to 3, which is negative 1, and then 0.6 is negative 1.6 for F2. Okay, now this point right here, that is your vertex. That's a vertex, and the coordinate of that vertex is 4 comma negative 1. And then this point right here is also your vertex. This is another vertex, and the coordinates is this point right here is 0 comma negative 1. Okay, all right, now let's label the asymptotes. Okay, so this is the first. Well, let's label the axis first. So this right here is known as your uh, conjugate or imaginary axis. So conjugate or imaginary axis. Imaginary axis, and it's given. This is a y-line, so it's given by the equation y. I'm sorry, x. This is an x line. It's the extreme slope, so it's given by the equation x equals 1, 2, x equals 2. All right, and then we have the this line right here. This line is the transverse axis. The line that goes across the graph is known as the transverse axis. The other one is the imaginary or conjugate axis. And this is a y-line since it's horizontal, so the equation is y equals negative 1. If you want to know the coordinates of your axis, use the center. Okay, the x coordinate is the coordinate of your conjugate or imaginary axis for this, and then your y coordinate right here, negative 1, is the equation of your transverse axis going through this point right here. All right. Now, next thing we need to find is our asymptotes. So this is the first asymptote right here. This is an asymptote. Okay, asymptote. And then we're going to write down the equation. So to write down the equation, I need the rise and the run for this line right here. And also, I'm going to write an equation for this one there too. So in this line, for this line right here, we're going down negative 3, and then the rise is negative 3, the run is 2. Okay, so the slope for this line is negative 3 over 2. So keep that in mind. So the equation for the asymptote is going to be y. You take the opposite of the center, the y coordinate, take the opposite of that, plus 1 equals. Now you need the slope because we're going to do, we need the slope, okay? So the slope is going to be negative 3 over 2 because that's the rise over run. So negative 3 over 2, that's m, and then x, and then you do the opposite of this number right here. What's the opposite of 2? Negative 2. All right, so that is one asymptote. The other asymptote right here is just like the first one. The only difference is the sign, okay? Asymptote. So I just switched the sign of this because it's the same direction, but it's just, this is rise and run. It's rising 3 and running 2. So this equation, I just switched this sign. It's going to be y plus 1, just like the first one. Y plus 1 equals 3 over 2 positive. This is minus parenthesis x minus 2. Okay? To get this one, you do the opposite of the y coordinate, and then to get this one, you do the opposite of the x. To get the slope, you just go rise 1, 2, 3 over run 1, 2. And then that generates your second asymptote. Okay? Alright, so that's that for the labels. Now we're going to state the meaning of what we just did. The meaning. Alright, so the locus of points on a plane whose absolute value of the difference the difference of distances the difference of distances between two fixed points. The two fixed points are, guess what, your foci. Fixed points f1, f2, which are negative 1.6 comma -1, and 5.6 comma -1. So the locus of points on a plane whose absolute value of the difference of the distances between two fixed points um, is constantly you just find the length of your real axis, the length of this, so you go 2 to the left and 2 to the right, is constantly 4, is um, is is the hyperbola as a hyperbola with the equation with the equation um, with the equation x minus 2, which is basically the original equation, x minus 2 over 4 minus y plus 1 square over 2 over 9 equals 1. Okay, so that's basically how you have it. Alright, thanks for paying attention to this clip. Remember, you can always subscribe to my videos on mathgutserve.com, and then you can also request any videos that you want, and hopefully I can help you out with it. Okay, so have a wonderful day.